In this video, I'll be going over lesson 6.4d, which is using trig identities to solve trig equations. Again, here are the trig identities as they appear in the booklet. We see the tangent identity, the Pythagorean identity, and the double angle formulas for sine and cosine. Here's an example that we did in the last lesson where we replaced cosine 2x with the identity that's in terms of cosine only. So I'm not going to repeat this one. Here's another equation. This has a 2 sine 2x equals 3 cosine x. It's asking for the solutions on the interval 0 to pi, which is a little interesting, so we'll have to remember that. So 2 sine 2x, I'm always going to replace a double angle. So I'm going to replace this sine 2x right away. I only have one substitution that I can use for sine 2x, so I don't have a choice. I'm going to replace it with 2 sine x cosine x equals 3 cosine x. If I'm going to simplify that, it is at least 3 cosine x. Now I'm going to look at this equation and I'm going to warn you about what not to do, which is do not divide by cosine x on both sides and think you can just get rid of it. Solutions will just disappear if you do that, in addition to the fact that you could be breaking a big rule and dividing by 0. You don't know if the cosine of x could possibly be equal to 0, and indeed it probably is, so do not ever divide by a term with x in it like that. Instead, let's try to get all of this on one side of the equation so that it says equals 0, and attempt to factor as we have been doing in many of our complicated trig equations. So now it's all on one side. The only sort of factoring I see that presents itself is taking out a cosine x from both terms. So if I factor out a cosine x, I'll be left with a 4 sine x minus 3 equals 0. I can now set each of these factors equal to 0 because it's factored and because of the 0 product property. Either the first factor or the second factor must equal 0. The first equation I'm actually ready to solve. This is cosine x equals 0. As I suspected, cosine x does equal 0 in this equation, and we're looking for where on the unit circle the x-coordinate is 0. And there are two places, so this is a pi over 2 angle, where the coordinates would be 0, 1. And this is a 3 pi over 2, where the coordinates would be 0, negative 1. But I remember from looking at the interval in this question, it's only asking for solutions between 0 and pi. So I'm only going to answer x equals pi over 2 for this equation. And then I'm going to come over here and look at sine x equals 3/4 and think, that's not a recognizable ratio from any of my triangles. So it must be a calculator question if I'm meant to go any further. So I'll go to the calculator and do inverse sine. And remember the complication that it is only going to give me one answer. So I'll add a calculator and do inverse sine, 3/4, and it gives me 0.848. Now, if you're not a fan of attempting to find the second solution, now I'm going to offer that perhaps you could use a graph instead. So if I was to add a graph page, the graph that you want to see is just the function sine x. It's going to create the wave, and now I have the power to change the window to only be looking at the interval specified, which is 0 to pi, so 0 to 3.14. This is the interval in question, and I wanted to see where it equaled 3/4. So if I added another function by going to entry function, if I add 3/4 as a function, it's going to create this line, and you can see that there are two solutions on this interval, just like we were expecting, because sine is positive in the first quadrant and the second quadrant. So I should have two different solutions. The 0.828 is going to be that first solution. So when I go to menu, analyze graph, intersection, there's the 848, not 828, in radians. So that's the radian angle that has a sine of 3/4. And then I can find the other solution by going to menu, analyze graph, intersection, and looking for the second intersection point. So 2.29. So 0.848. Which question were we working on? This one here. 0.848. And the second solution, which I've already forgotten, 2.29. 2.29. So you can use the graphical approach when you're going to the calculator anyway, or you can use the inverse sine approach, which only gives you this quadrant answer, and then you have to find that same answer in the other quadrant. And these are in the interval 0 to pi. Those are the only solutions, so I'm done with this question. Another common thing they ask us to do with our identities, and this would be a non-calculator question for sure, it says exact values, is given a ratio like 1/4, so not one of the ones from a special triangle, we're supposed to find another trig function like sine x, and this is all without ever knowing actually x. They do tell us that x is between 0 and 90, so if it helps for you to sketch, you can sketch an angle in that quadrant. And what we can do is create a triangle where x is the angle. And knowing that the cosine is 1/4 means I know the adjacent side is 1 and the hypotenuse is 4. I can find the sine by using this triangle because I know sine is opposite over hypotenuse. I just need to find the other side of the triangle. And for that, I have the Pythagorean theorem. A really common IB Math SL question. So 4 squared is 16 minus 1 squared, which is 15. So b ends up being the square root of 15, and we're meant to leave it that way. It's asking for exact answers. So the sine of x is going to be root 15/4. Now the sine of 2x does not mean to double the sine of x, right? That would be if there was a 2 in front of the sine, which there is not. It means to double the angle, and we don't know the angle. So instead, we use an identity. We always use an identity for double angles. And you'll notice that the double angle identity for sine has 2 single angles in it. And I know the sine of x, and I know the cosine of x. So I'm going to keep the 2. The sine of x is root 15/4. I just found it. It's not the sine of root 15/4, right? Root 15/4 is not the angle. It's actually the sine of x without ever knowing x. And the cosine of x was given in the question. And then it's just a matter of simplifying. 2 times root 15 times 1, 4 times 4, and then you can simplify your fraction if possible, and that's the value of sine 2x without ever knowing the actual sine of x. Without ever knowing the actual angle x. That's it this time.